Alright, so this is the problem I chose for my double integral extra credit, and it says write and evaluate an integrated integral that corresponds to the function f right here, which is equal to xy, over the shaded region R, which you see right here, and it is bounded by the y-axis, the line y equals x, and the circle, this portion of the circle here, x squared plus y squared is equal to 2. And so we know the radius is equal to root 2. And so first, let's do the integral in the dy dx direction, because as we'll see, that is the more efficient integral to solve. So I'm going to start by developing our parameters. So here we go, and then dy dx. And so our parameters here in the y direction are going to be, and also it's important to note we only need to do one integral in this direction, because in the y direction we can use this equation because it covers this quadrant, and then we can also use this equation in the y direction. So with that, we can rewrite this equation as y is equal to square root of 2 minus x squared, and so that's going to be our top parameter there, 2 minus x squared, and then our bottom is just going to be this line here, so y equals x, so it's just going to be x, and then in the x direction we are going from this point, this line here, to this line here, the y-axis. So we know that the bottom parameter is going to be 0, and then the top parameter we have to get here. So we can set, so we know y equals x. We basically want to find where these equations intersect. So y equals x, so we can rewrite this as x squared plus x squared is equal to 2, and then we see 2x squared is equal to 2, and then those cancel, and we get 1 on this side, and then we get x is equal to plus or minus 1, because the square root of 1 is equal to plus or minus 1. And then we know that we want the positive one as the top parameter here, because because it's in the first quadrant here. If it was to be in this quadrant, then we would want negative 1. So we know it's positive 1. So now we can just evaluate the integral. So we're going to start with this here, so 0. So first we want to integrate this, and we get xy squared over 2, because the x is considered a constant, and then we're doing that from 2 minus x squared to x, and then dx, I'll make sure we keep that, and then we will get x times 2 minus x squared over 2 minus x third over 2. Alright, and then that's dx, and then we want to go ahead and simplify this, and when we do, we see 2x over 2 from this term here. If you distribute that x, you get 2x, and then put that over 2 and leave it as its own term, and then so that'll just be x, and then we want to deal with this term, so that's going to be minus x to the third, and then over 2 as well, and then minus x to the third over 2, and dx 0, 1, and then we see that, oh, we can actually just get x minus x to the third, makes things a lot easier, and then from 1 to 0, and we can go ahead and integrate with respect to x, and we get 4, and that is going to be from 1 to 0. And yeah, so we get 1/2 minus 1/4, and then minus 0, because if you plug in 0 to both of these terms, you just get 0. And so now we just have to deal with this, and we know that this is the same thing as 2/4, and so we end up just getting 1/4 as our final answer. And now we want to go ahead and look at the other direction of integration, which would be dx dy. And this gets a little trickier because if you look at this graph here, you can't actually integrate with just one integral, because there are two different equations happening over here on the right side, which would be like the top parameter in the integral. So we're going to need two integrals. We're going to need to break this up. And the way we do that is by basically making a little dividing line right here. And then, as we said earlier, this is 1, 1. That's nice to know, because y equals x. And then we want to basically make an integral for this area, and then also one for this bottom area here. So let's deal with this top area first that has to do with the circle equation there. So we want to do with this. So x, y, let's write out basically the backbone of the integral real quick. So now we're doing dx dy, and if we look at, so in the x direction, we're going to be going from this equation over here on the right. That's our top parameter, which can be rewritten as x equals square root of 2 minus y squared right there. So we get square root of 2 minus y squared. And then looks like our left parameter, bottom parameter over here, is going to be just x is equal to 0. So we just put a 0 there. And then in the y direction, we are going from this line, which is y is equal to 1, and actually y is equal to square root of 2. Sorry, because the radius of the circle there is 2, so we know that when x is 0, y is equal to square root of 2, so square root of 2 corresponds to that point right there. And then we are going down to 1, because we're just dealing with this little area right here. So 1, because that corresponds to y equals 1, to obtain the full scope of the integral. So, in the dx dy direction. So we're going to want to go ahead and deal with that bottom area now, and you see that if we write the backbone here real quick. In the x direction, we're now dealing with y equals x, that equation there, as our right or top parameter in the case of the integral in the x direction. So we can just write y here, because x equals y, and then for the bottom, we're also dealing with just the y-axis here, which would correspond to x equals 0, so we just write a 0 there. And then in the y direction, we are now going from this top line, which would just be y is equal to 1, so we have a 1 there, and then in the and then for the bottom parameter, we just have 0 because we want this line here, and when y is equal to 0, it's just that line, the x-axis, so 0. Now we can go ahead and solve. So I'm just going to break these up. So let's solve this first one, and then we'll do the second one. So bring us down here. We have square root of 2, 1 root 2 minus y squared, 0, x, y, dx dy, and let's go ahead and integrate really fast, and if we integrate we get x squared, because y is considered a constant in this case, over 2, pretty easy stuff there, and then we get square root of y squared, keep the parameters, dy, and then we can see that we get 2 minus y squared y over 2, and then minus 0, because if you plug in 0 to the x squared there, you just get 0. And then obviously we want to keep this stuff, y. And let's go ahead and simplify this really fast. And so we get 2y over 2, if we're just dealing with this term here, if we distribute, minus y to the third, if we distribute there, over 2. You can actually cancel those 2's, that makes it a lot easier. And now we are left with square root of 2, 1, and now I can go ahead and integrate with respect to y, so y squared over 2 minus y to the 4th over 8, and now we just keep the parameters, and then we get 2 over 2 minus, so that would just be, let me think about this, just be 4, because if you square 2, you square it again, 4, over 8, and then minus 1 over 2, minus 1/8, and then you get, this is the same thing as 4/8, and then we have, if you simplify this down, you get, that's 8 over 8 minus 4 over 8, so 4 over 8, minus 3 over 8 for this here, because, and then you get 1/8. And that's for our first integral here, so 1/8, that's our first term there, and then we want to figure out this integral now. So let's go ahead and do that, and we will do that right here. So square root of 1, 0, y, 0, x, y, dx, dy, and go, and oh yeah, just again, this region here, this top region corresponds to this integral, and then the bottom region corresponds to this integral, which we're now solving. So that was the area, or that was the value for this area here, this region here. Now we're going to do the value for this region. So here we go. So let's start by integrating, and that's just going to be the same thing as over there. So x squared y over 2, and then from y to 0, dy, yeah, and then 1, 0. And then we just get y to the 3rd over 2 minus 0, and then from 1 to 0, dy, and now we integrate just this term here. Don't have to worry about the 0, so then we get y to the 4th over 8, and then that's from 1 to 0, and we get 1/8 for that term there, for this guy. And now, if we add those together, we see that we get 1/4. 1/8 plus 1/8 is, in fact, 1/4. So, whichever direction you choose, you'll get the same answer here. Obviously, that was the whole point of this. And it's nice to know how to be able to do this direction as well when you're dealing with a weird circumstance like this where you have to split it up into 2 different double integrals. But as we can see, the dy dx direction was far superior in this certain situation. So hope you enjoyed the video, and thanks.